Hey guys, IE.RVT here, and we're currently looking at Module 5, Homework B, Tab 1, Part 1, Series Capacitors Total Capacitance. So, for capacitors in series, the total charge stored by each capacitor is the same, and we let the charge on each capacitor be denoted by capital Q. And given that the voltage across the entire series combination is capital V, the voltage across each capacitor V1, V2, and V3 must sum up to V since the voltage adds in series. So that's capital V is equal to V1 plus V2 plus V3. Each capacitor obeys the fundamental relationship between charge, capacitance, and voltage. So we can go ahead and write this out as Q equals C1 times V1 is equal to C2 times V2, which is equal to C3 times V3. And we have V1 is equal to Q all divided by C1, V2 is equal to Q over C2, and V3 is equal to Q divided by C3. Since V is equal to V1 plus V2 plus V3, we can substitute the expressions for V1, V2, and V3 in terms of Q and their respective capacitance. So then we can get V is equal to Q all over C1 plus Q all over C2 plus Q all divided by C3. So now we can go ahead and factor out capital Q from the equation, and we get V is equal to Q, then in parentheses 1 over C1 plus 1 over C2 plus 1 over C3. And by definition, the total capacitance C sub T is the ratio of the total charge Q to the total voltage V. So we can go ahead and write that out as C sub T is equal to Q divided by V. From the equation above, we can solve for C of T by substituting for V. So pretty much we can get C of T is equal to, in really long division sign, we get Q on top, and it's going to be Q times 1 over C1 plus 1 over C2 plus 1 over C3. Okay, maybe I was exaggerating a little bit with this division sign. And we can go ahead and simplify that out to be C sub T is equal to 1 divided by 1 over C1 plus 1 over C2 plus 1 over C3. And this is the expression for the total capacitances of the three resistors in series. So this is what you should be putting into state physics. If that doesn't work, might be entering error or something like that. So pretty much this equation shows that the total capacitance of capacitors in series is always smaller than the smallest individual capacitance because the reciprocals of the capacitances add together. And I hope this helps.